Your time is up. So we started out last class learning the multiplication properties of exponents. Let's see how well we're understanding so far. Number one, what is the end result when you simplify that complicated looking expression? We'll start with Alyssa, Tristan, Alicia, and Sharik.
5 times h to the 10.
Okay, what'd you get? Okay, Alicia?
5 times s times h to the 20.
Okay.
5 times h to the 24.
So we've got some different answers, but 5h.
Can I just say something? Can I just say something? I
understand. It's fine. It's fine. It's an honest mistake. We'll get back to how in a few minutes, and we'll also survey and see how everybody did. Well, let's get the answer for number 2. How do we do on number 2? We got Brandon, Anissa, Kamoy, and then Brian.
26,234
Okay. So you got the same exact thing he did. Okay, Kamoy, what about you? Draw?
I tried some number far away from it.
But how do you know that they're not both wrong and you're the one who's right?
But this one, 765 times s to the power 12 times t to the power 14.
Okay, so it sounds very similar. You just had a different number up front. Brian?
26,234.
Okay, so in this case, they did happen to be correct, but I didn't lie to you. I just presented the possibility that you might be the one who's right and everyone else was wrong. Now, clearly you know what you're doing because you got a large part of it right. You just made a small mistake on a number. And honestly, it was probably the difference between like one number. So the idea here is to now figure out what small mistake you made to try and concentrate on those little ideas. So, specific questions on either of these. We'll start with Catalina and then over here.
I got, since I read right your answer as a power, I understood that we weren't supposed to actually do it for like -6 to the second and 9 to the 3rd.
So is your answer -6 to the second, 9 to the 3rd, s to the 12th, t to the 14th? Then I'll accept that. Okay? You're right. The instructions tend to be a little confusing. I guess I could have been a little more clear. With numbers, and honestly, sometimes the publisher expands the number and sometimes it doesn't. I don't know. I can't figure out quite exactly what the rule is. But if you can expand the number aspect of it, in other words, the -6 to the second and the 9 to the 3rd, if you can do that part, go ahead and do it. Okay? Tristan, you got a comment or a question? You don't understand? Well, what was your answer?
15 times
Okay, so your answer, does it seem like your answer is very far off from the actual answer? Okay, so you're saying I don't understand, but actually you really do. You have to find where you made a mistake. Because now you can see the correct answer. It was supposed to be a 5 and you put a 15. So where is the disconnect? So you got to find that issue. Before we get more into how these were done, let's find out how everybody did. Give me a thumbs up if you got both of them right. Okay? 3, 4, 5, 6, 7. Put your thumbs down. Okay, so about 1/3 of my class. Okay? Give me a thumbs up if you got one of them right. Okay, 1, 2, 3, 4, 5, 6, 7. Good, put your thumbs down. So 2/3 of my class got at least one of them or more. Okay, good. So let's find out where we're going wrong or what needs to be adjusted. So, has anyone been able to find where they went wrong already? Sebastian, which number? Yeah. Okay, hold on. You got 1 over Okay, you got 1.
You put it on white.
1 over 125 times what?
625.
Times 625. Now hold on a second. So you did the 3 to the 1/5, and that's where we got this. Where'd you get the 625 from? Good. I'm just asking, where did you get it from? Be specific. Okay. The 5 and what? Yeah, so you use power of a power. You got 5 to the 4th power, which is 625. Very good. So now, right now, that's all my students who got the number wrong, the coefficient. Look back at your work. Do you have a 1 over 125 somewhere and a 625 somewhere? Because that's it. 625 divided by 125 is the 5. I know your issue. I know what happened. It's fine. Don't worry about it. So now the second, go ahead, Sebastian. I'm sorry. Okay.
I stopped there and I forgot to divide the 625 by 1
Okay. All right. I mean, look, yours is mostly correct. You just have to continue going until you can't simplify anymore. But the second part, for my students who somehow messed up the variable part, this is power of a power. H to the 4th to the 3rd. This power is applied to this. H to the 4th to the 3rd. What do you do for power of a power, which is, of course, my favorite property? Maria? Yeah. So this is h to the 4th to the 3rd. The shortcut is multiply the exponents, and you get h to the 12th. So we did the numbers, and then we put them together out front. Now we're doing the variables. And now we have to do that again here, following Maria's guidance. Excuse me, h to the 2nd to the 4th is h to the 8th. So the answer was 5h to the 20th. How do we get the h to the 20th from this? How do we get that part? Kezekiah? Okay, well, I want to be clear about something. I did make reference to like terms, and I said that there's a similar feel to like terms. These are not like terms. Like terms have the same variable with the same exponent. And when you add them, you add the coefficients. That's something you learned a long time ago. Don't concentrate over there, Kezekiah. Listen, because this applies to you. So, this is not like terms. This is multiplication of two expressions that have the same base. And so what are you allowed to do when you multiply two expressions with the same base? You add the exponents. Could someone tell us the name of that property? Which you are supposed to know off the top of your head. Anissa? It's a product of a power. Because it's product multiplying powers. And so we add the 12 and the 8, that's a shortcut, and that's where we get the h to the 20th. Any comments, questions, or concerns on number 1? Ania? Okay, so you got 3/5. Good. Do you understand now the difference? Do you know where we got the 1 over 125? Good. Other comments, questions? Okay. The idea was the same in number 2. Same approach. It was a very similar question. You just have to keep track of what you're doing. Okay? Come on. What was it?
I added 729 and 36 and 7.
Okay. So you got a 36 from this. And then you got a 729 from that. And then you were supposed to multiply them together to get the 26,000, whatever it was. But you got whatever it is when you add them. Okay. Very good job. So now you know to be aware of that mistake in the future. Excellent. Other comments, questions? Good. Today we're going to expand our understanding of how exponents work by exploring division properties. And our goal is really to be able to, by the end of today, simplify an expression that involves multiplication and division of powers. That is our goal. So we're going to take a similar approach to what we did last time. We're going to do building blocks. We're going to learn a new property, understand it in and of itself. We're going to learn a new property, understand it. Then we're going to start incorporating all of the properties. By the end of today, you will have 5 properties of exponents that you will have to know, and how they relate to each other and how they can work together. So, the first of the division properties is the quotient of powers property. Last time, the first property you learned was the product of powers. Product of powers was when you were multiplying 2 or more powers. Today we're dividing 2 powers. When you divide powers that have the same base, subtract the exponents. Which, when you think about it logically, makes perfect sense. Because when we multiplied powers with the same base, we added the exponents. Multiplication, the trick was adding. Division, the trick is subtracting. So here's what it looks like. Very formally on the left. A to the mth power over a to the n. We have division, same base, we subtract the exponents. Here's a practical example. 4 to the 7th power divided by 4 to the 2nd power will be 4 to the 5th power. Now, if you can handle that and you can do it, great, go ahead and do it. I think there's an issue here, and I've seen it happen a lot over my years teaching this. So I'm actually going to teach you something else. I will leave it up to you to decide what makes sense to you. However, I'm going to say that my method eliminates certain issues. So I actually do not use this property the way the publisher demonstrates it. Yes, I end up subtracting, but I don't really look at it that way. Here's what I do, and I don't want you to write this down yet. Here's what I see. Here's a 4 to the 7th power. So I know in my head that that is actually 4 times 4. That's 7 4s being multiplied by each other. And on the bottom, I see 4 to the 2nd power, and I know that there are 2 4s being multiplied by each other. So now, what happens when you have any expression, a number, over itself? So let me hide this for a second. What happens if I have, 8 over 8? What does that equal? 8 over 8. Kayla? It equals 1. What if I had this expression? What would that equal? Anil? That also equals 1. One way to think of it is this. This 8 is going to cancel this 1. That 8 is going to cancel that 1, and so we have a 1 left on top, a 1 left on the bottom, which is really just 1. So this is, since I am an expert at understanding that, I'm going to use that idea to deal with division in a slightly different way. Now, I see that I have that 4 canceling that 1. I have that 4 canceling that 1. Now I have nothing left on the bottom except for a 1, and I have 1, 2, 3, 4, 5 4s on top. And so I end up with 4 to the 5th. Doesn't seem like very much of a shortcut, does it? Having to write it all out, but that's not what I'm expecting, and that's why I told you not to write it. This is what I expect you to do. So let me back up. Here's what I expect you to be able to say. I expect you to be able to say to yourself, okay, in my mind, I see that there are 2 4s. So you're actually, in your mind, converting this to 4 times 4. And in your mind, you should see 7 4s going across the top. So you should be able to say, considering how high level you guys are, you should be able to say to yourself, these 2 4s are going to cancel 2 of the 4s up here. So I'm going to cancel 2 of them. So I'm going to cross out just the exponent. How many 4s do I have left on top? Anissa? 5 of them. And I'm representing that with an exponent, and so I am left with 4 to the 5th power. And so you end up with the same thing. Here's why my approach solves some problems. What if I gave you the same thing except it was flipped over? What if you had this? 4 to the 2nd power over 4 to the 7th power. If you follow the publisher's approach, you're supposed to subtract these. And so that will be 4 to the 2nd minus 7, which is 4 to the negative 5th. I'm going to teach you in the next lesson that you're actually not supposed to write answers with negative exponents. So now all of a sudden, if you follow what you're taught by the publisher, you end up with a negative exponent, and that is then actually a bad thing. So if you take my approach, watch my approach. Two 4s on top are going to cancel 2 of them on the bottom. And how many will I have left on the bottom? Sharik?
5.
5. And so now look what I end up with. I have nothing on top, but that means there's a 1 on top. And I have a 4 to the 5th on the bottom, no negative exponent. You're going to learn next time that a negative exponent actually means that, but we're not going to get into that now. So again, you can use either approach. I don't care. But my approach does solve certain problems. The problems that I'm talking about aren't going to come up that often, but it does solve the problem. Okay? So that's the quotient of powers property. Brandon, comment or question, go ahead. Okay, well I think you're talking about something that maybe feels the same, but it's a different idea. And you're going to learn about radicals again this year as well, later on. Alicia and then Nina. No, you have to do top minus the bottom. It has to be the top exponent minus the bottom exponent. It has to go in that order. Okay? Ania. Well, if there's nothing left on top of a fraction, are you allowed to write something that looks like this? Have you ever seen anybody write anything like that? Okay, so we don't. Because there's supposed to be something on top of a fraction. And that's a 1. Okay? If there's nothing there, it doesn't mean that it's 0. It means that there's a 1. And that's a little bit hard to understand, and I understand that. Try not to worry too much about it right now. It's not going to come up that often today. Kamoy, and then I got to move on.
Doesn't that mean repeating though?
Repeating? Oh, the bar? It means repeating when it's a decimal. You're talking about this. Okay? Good. So that's one property for today. The second property, you actually already know. It's called the power of a quotient. And last time, you learned power of a product. It's the same thing, except instead of multiplication, it's division. And what it says is, if you have a division problem, all being brought to a power, that the top and the bottom both get brought to that same power. So here's a practical example. X over y, the x will get the power of 6 and the y will get the power of 6, just like this. Comments, questions? I got to move on, Brandon, and then as it comes up during the different examples, I'm sure it'll apply to something, okay? So as I said, we're going to take the building block approach. We're going to do one property, then the other, and then we're going to put it all together. Okay, but it's going to happen pretty quickly. So here we go. So with something simple like part A, you should instantly know what the answer is going to be. Simplifying that expression. You can use the publisher's method, which is just subtract the exponents. Top exponent minus bottom one, so you know that it's going to be what? Sebastian? 6 to the 7th power. Okay? The other approach was what I had described, which is looking at it like this. I know in my head that there's 5 6s going across the bottom, and here there's 12 6s going across the top. These 5 are going to cancel 5 from up here, and so we get 6 to the 7th power. Comments, questions about that? Now you're going to see how this method can help a little bit with something more complex. But we're also going to view this 2 different ways. So look at part B. We've got negative 3 to the 3rd power times negative 3 to the 9th power all over negative 3 to the 7th power. All 3 powers have the same base. So that tells you got a lot of flexibility. In fact, this is where I said that it becomes puzzle-like, and it's your challenge to try and figure out what makes sense to you and some different ways of doing it. So now let me propose this. What if I asked you just to do that? What would you get? Zabari, what do you think? Okay, Jada, what did you think? Yeah, that's negative 3 to the 12th power. What property is that they just used? Kamoy? Product of the power. Very good. So we know that the top is negative 3 to the 12th, and the bottom is negative 3 to the 7th. Now, we only have 1 on top, 1 on the bottom. We can subtract the 2, or do what I described, which is say to yourself, there's 7 down here. It's going to cancel 7 of them up here, and so that leaves 5 left over, and we get negative 3 to the 5th power. And that is the expression. The other approach would be this. The other approach would be to say to yourself, well, I got 3 right here, and I've got 7 of them down here. That's 3 negative 3's, and I'm going to cancel out 3 of them down here. I'm left with 4. But now I've got 4 on the bottom, and I've got 9 of them on the top. These 4 are going to cancel 4 of those, and I'm left with 5. And I get the same result that way as well. It's up to you to decide which way makes sense to you. Kamoy and then Zavar.
Isn't negative 3 and power 5 kind of like the answer to that question? Like, instead of just simplifying that, just the answer?
You mean, should we expand that and actually multiply it out, negative 3 times negative 3 times negative 3, or should we leave it like this?
Yeah, if you do that, it would just
I'll accept it either way. When you get to exponents that are higher than 4, expanding it by using your calculator starts to become a bit of a pain. So you can leave it like this. Okay? Zabari? Yep. So that's why I was saying, so you just discovered a different approach. And it's all about where your mind kind of sees things. Okay? Very good, Zabari. Any comments or questions? Anita? Okay, so part C. So now we introduce algebra, meaning we're now just dealing with variables. But the same principle applies. We now have 5 properties to use. Use them however you can, following the rules. So you've got a whole bunch of choices. You can use Zabari's thought. You could use one of the things I said. You could do it formally by simplifying the bottom and then doing it. Let's start there. Simplify the bottom because it's a multiplication. What do we get as a result of that? Tristan? Z to the 10th power. Good. Z to the 10th power. So we get, on the bottom, Z to the 10th power. What do we have on top, Tristan? Very good. You said that perfectly. Z to the 20th power. And now you can subtract the 2, and you can see the result will be Z to the 10th. Or you could just, from the beginning, say to yourself, well, there's 8 down here, and that's going to cancel out 8 up there. And I'm left with 12 of them. And then I've got 2 here, and that's going to cancel out 2 there. I'm left with 10 of them. Either way, you end up with the same results. Comments, questions? Part D is here to illustrate one additional idea that for some reason students get stuck on. What does this really mean when you have something that looks like this? What does it really mean? Catalina?
I interpret it like 1 over y to the 9th power times y to the 12th power over 1.
Okay, so you see that, and then you said do what?
Multiply across and then
Right, so you multiply straight across. And you're absolutely correct. I would go a step further, and I would just understand that I know this is really up there. That's really what is happening. When you have a 1 on top of a fraction multiplied by something else, that is really going to go on top. And like she said, that's y to the 12th over y to the 9th. And now use one of the methods that we've talked about. I didn't understand the beginning of what you said. Yeah. Well, we didn't cancel it out yet. You're talking about here? Okay, the base is the same. So now we can use one of the properties. In fact, all the properties only work when the bases are the same. Okay? Is that what? I still don't feel like I understand your question. Are you clear or no? Okay, good. So now you can just subtract them or use my method and you end up with y to the 3rd. Comments or questions? Okay, give it a whirl on your own. You got 2 questions. Let's see how you do. And yes, in part A, that is a -3. I did that on purpose. put pens up. Let's see how we did. What'd you get for part A? We'll start with Ania and then Sharik. Okay.
X to the 15th power.
Okay. The correct answer is x to the 15th power. What about part B? What do you get? We'll start with Kamoy and then Stephanie.
-8 cubed.
Okay. -8 to the 3rd power. Very good. Give me a thumbs up if you got both of them. Good. Put your thumbs down. First building block securely in our minds. Now moving on to the next. So we're only doing 2 examples of this because you already know what to do. You just never saw it in a division form. So, simplify the expressions. Write your answers as a fraction in simplest form. Now we have a fraction, r over s. This is a division problem, and the whole division problem is being brought to this power. This situation is just like power of a product. We are now we're now bringing this exponent to this, and we're bringing the exponent to that as well. So it's r to the 5th power over s to the 5th power. Could someone explain why I cannot do anything else to simplify this? Why can I not go any further? Alicia? The variables are like numbers or letters?
I said that? I meant because they're letters.
Okay, that's true. It's true, but, well, if it was, what if it was x over x? Would I be able to do anything with that? That's right. So even though they're both letters, I could do something. So that's not really the reason. So my question is, why in this case can I not do anything further? Shelby? Good. The bases are not the same. If the bases were the same, then we would go further. But since they are not the same, we must leave it like that. Comments, questions? Part B is here to illustrate the same idea, but with one extra detail that you need to be aware of, and you already know the detail. What were you taught to do when you have a negative sign outside the middle of a fraction, when you have to actually then work with it? What were you taught to do, Anissa? That's right. So where do you think we should put it? Yeah, usually, not always, but usually makes more sense to put it with the number. So you have to move it either to the top or the bottom. Very often it works best when it's with the number. And so what this really means is -4 over w all to the 3rd power, and here's what it translates to. -4 to the 3rd power over w to the 3rd power. If you wanted to, you can now do -4 times -4 times -4, or leave it like this. Comments or questions? So we're not having another checkpoint because I feel like you should already know what's going on here. So now we're going to jump to the higher level stuff where we incorporate everything you've learned. So, example 3. I want you to keep in mind as we're working through the next few examples what I've said several times, which is this is supposed to seem puzzle-like and challenging in a way that was different than other stuff we've done. When we studied systems of equations, you ended up with 3 different methods for solving them, and so you sort of had a choice. But it wasn't really a creative choice. It was really just, okay, I have to choose one of these methods. But now you actually get to be creative with math and see how creative you can be in trying to simplify something. Who could simplify it in the least number of steps? That's really what I'm asking you. And so we're going to do this one way, but then we're going to look a little bit deeper to see if someone can discover, or several people, or a bunch of people, can discover a more efficient way of simplifying it. So, technically speaking, I have a power outside of a whole expression. I have to deal with this first. And here's how you deal with it. It's exactly what you just learned. This power gets applied to every factor and the numerator and the denominator. So here's what it's going to look like. The 3 is going to be brought over here, 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 and it's going to be brought here, here, and here. That looks pretty messy.
Yes.
But let's work through it. So we're bringing it to the 6, so we've got 6 to the 3rd power. Now, to help myself, I am also going to start including multiplication dots so that I can see things clearly. This is a very important piece of advice that I'm giving you now, and then I'm going to emphasize even more next time. Now I've got m to the 3rd to the 3rd. What will that become? M to the 3rd to the 3rd. Hezekiah?
I'm sorry.
M to the 9th power. Does anyone know what property that we just used? I'll give you a hint. It's my favorite. Oh, a lot of people know now all of a sudden? Okay. Alyssa?
Power.
Yes. Power of a power, my favorite. And so then we have n to the 2nd to the 3rd. What are we going to get as a result of that? N to the 2nd to the 3rd. Sebastian? N to the 6th power. Very good. The top is now done with that exponent. Now let's take care of the bottom. 3 to the 3rd power. Times, now it's a little bit easier because there's a power of 1 on both of these. It's really m to the 3rd power. And then it's n to the 3rd power. Now, we've got most of the work done. We just need to find areas where we can simplify things. We don't know, these numbers will probably be able to divide because that's a 6 and that's a 3, and there's a good chance we'll be able to divide them. So we do need to expand this and this. We also need to look for same base on the top and bottom so that we can cancel things out. So let's start with the 6 to the 3rd power. What will that become? 6 to the 3rd power. Tristan? Kamoy?
2. Because the 3 and the 3 cancel each other out. And then
No.
2 to the,
You cannot do that because these are not the same base. So I'm just focusing on this. I'm sorry if I went too fast. If this was a 6 and that was a 6, then you could do something with the powers, but you can't. Not the same base. Jada? That's 216. So that's 200. Oh, I shouldn't have done that. Sorry. That's 216. And what about the 3 to the 3rd power? What does that become? Alicia? 27. So 216 over 27. And now let's deal with this and this. Right now, your eyes should be focused right here. And look, it's set up perfectly in a column for you. M to the 9th over m to the 3rd, what will that become? A lot of people seem to know. Brian? M to the 6th. So we took care of that. What about n to the 6th over n to the 3rd? What will that become? Kayla? N to the 3rd power. Now we just need to see if those two are divisible, and let's see, are they both divisible by, that's divisible by 9, that's divisible by 9. It's divisible by 3, divisible by 3. They're probably both divisible by 27, aren't they? Maria, what does it come out to? 8. So, we get 8. 8 m to the 6th, excuse me, m to the 6th, n to the 3rd, and there's nothing else that can be simplified. Comments, questions about what was just done? Here and then there.
Instead of trying to see what they're both divisible by, in some cases, can't you just divide
You can try that. I mean, I would try that first. Okay. Yeah, if you try that first, great. But just if it doesn't work, it doesn't mean that you can't simplify it. Okay? It just means that it wasn't perfectly divisible. Okay? Hezekiah, and then in the back. No. And that's why my method is really important. Because look, this really means that there are 3 m's. This right here means m times m times m on the bottom. This means there's 9 of them on top. And it's gonna keep going. This one cancels this one cancels this one, that one cancels that one. There's none left on the bottom, the rest of them are all on the top. That's why my method's important. Because that's what happens is students get confused where the expression is supposed to go. Is it supposed to go on the bottom or is it supposed to go on the top? So that's why my method takes care of that issue. Okay? Here's the creativity part. So now I want you to go back to the original question. Okay, I'm going to rewrite it. I'm going to give you a hint that there was a completely different approach that we could have taken. Anyone see it yet? Okay, give me a thumbs up if you think you see a different approach. 4 people see the approach, 5, 6 people see it. Okay, maybe you see it. We'll see. Brandon, what do you see?
Wait, can you do that?
Go ahead, keep going. I got some people frantically seeing it now. Okay. Okay. Brandon, someone's going to tag team for you. Sharik, go ahead.
Okay. You don't have to multiply the exponent with that cube. You can just simplify what's in the fraction and then afterwards
Good.
No, that's what I was going to say.
That's what you.
That was
No, but
Brandon
Brandon started us off with having trouble kind of getting the thought out. Sharik's kind of crystallizing the thought. Now can someone be specific? Give me something specific I could do. Maria?
First, you divide 6 divided by 3.
Yeah, look, 6 divided by 3, that's 2. What else can you do, Kamoy?
Oh.
See, now I called on you, and now you just...
No, because he said you can do it all in the fraction once, but what I was thinking was after you do that, then you just automatically do it to cube it part, and then you just like write down 8 and then do the next one. That's how I was thinking. I don't know.
Okay, we'll come back to you in a second. Zabari.
Everything over n1 will be equal n to the second.
Right, so this and this will become m to the second, and what else can you do? Go ahead, Brandon.
You could do n, or you can do n squared over n and get n.
Very good, and now bring it to the power of 3. And now watch how different of an experience this is. Because now we got this here, and this here, 2 to the 3rd power. M to the 2nd to the 3rd is m to the 6th. n to the third is n to the third, and we know now that that is 8, and you end up with the same exact result. Which column looks simpler just by looking at it? Which column looks simpler, the work we did on the left or the work we did on the right? In your opinion, I mean, it's kind of a giveaway, Alyssa, but which one looks simpler? The right. So I honestly do not care which way you do it, because sometimes your brain's going to catch things and sometimes it's not. And so it's really just a matter, again, of just your focus and concentrating and being creative, okay? Ania and then Brandon, and then I got to move on to the next couple of things.
Would you be allowed to write the second one and
This here?
yeah.
That's what I'm saying, is do whichever one you want.
But the end result, would you have to
Oh, this part? 2 to the third power is easy to do, so you should just do it. Okay? If it was 2 to the 20th power, then don't worry about it. 2 to the third power you can do in your head, okay? Brandon?
The right side is PEMDAS because
That's right, is that we kind of, even though PEMDAS is the rules, there's some flexibility depending on what operations are being done. And when you have just multiplication and division, you actually have a lot of flexibility. Notice that there's no addition or subtraction anywhere. When you put in addition and subtraction, that's when things become really hard. When it's all multiplication and division, you've got a lot of flexibility, okay? So let's look at it again with a slightly different one. Now, there was one aspect of the first example, the top example, part A, that made things a little bit easier, and hopefully you'll see the difference here. Now, in this case, now that we saw the approach that could have been taken in part A, we should immediately look in here and see if there's anything we can simplify. And unfortunately, there is nothing. And so in this case, we're going to have to apply the exponent to everything right at the beginning. And so here's what we end up with. 2 times s to the 4th over t times, and now it's going to be 2 to the 3rd power times t to the 3rd power over s to the 3rd power. But here's something that you should have internalized probably a couple of years ago. When you're multiplying two fractions, you multiply the top times the top and the bottom times the bottom. So even though it looks like this is an expression and this is an expression and it looks really complex, here's what you're really looking at. You're really looking at one large expression. And in fact, you can now, when there's only multiplication and division, you have a lot of flexibility. For example, in this top example, the m's were on top of each other and the n's were on top of each other. In this example, they're not, but that doesn't matter. You have two choices. You can either move them or just know in your head that they go together. Your mind should be able to do this with no problem whatsoever. Your mind should be able to understand that this could really go right over here and take the place of the s to the 4th, so it was on top of that t. Or your mind should be able to understand that that t to the 3rd power is on top, and it has the same base here on the bottom, and those two go together. And your mind should easily be able to pick up that s to the 4th goes with this on the bottom, and that we have this and this. Your brain should be able to handle the fact that it's kind of diagonal from each other. And so here's what, I mean, again, you can subtract just like the publisher said, or say to yourself, well, there's 1t, and now I had 3 on top, now I've got 2 left over. And here's 3 s's, and I had 4 on top, I'm going to have 1 left over. And now I have a 2, and then 3 more 2's. How many 2's is that altogether? Brian? 4 of them. So 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is 16. And so I end up with 16 s t to the 2nd power, and that's it. There was nothing left on the bottom. Technically, it's over 1, but when in algebra, and actually in all math, we don't write that, we just leave it like this. And so that is the end result. Okay? Kamoy and then Brandon.
You know how you said, just like diagonals, it's not just like cross multiplication.
And I don't want you to get confused. That's not cross multiplication. Cross multiplication refers to a proportion when you have an equal sign between two things. That's cross multiplication. This is not cross multiplication. Okay? Brandon?
You know how for the second fraction, they all have the same exponent. Could you take away all the exponents since they have the same?
No. You want to cancel all the exponents because they're all the same? You can't do that. That's your, because you have to think about what it means. This is what you're saying. If it's x to the 3rd over y to the 3rd, can I do that? But I want you to think about what x to the 3rd over y to the 3rd really means. And this is important because I have another student in my other class who's getting very confused with this idea. X to the 3rd really means x times x times x, and this really means y times y times y. Can I cancel any of that? So would it make sense to cancel the 3 and the 3? No. Okay? It would. I'm sorry? It wouldn't work? Okay. But that was good that you did that. Catalina, and then I gotta move on. That's right, it's not the same base. Okay, very good. Checkpoint number 2. See how you do on your own? keep working. Take another minute. All right. Let's see how we're doing. What'd you get for part A? Start with Kamoy, Jada, and then Sharik.
8y to the power of 16 times z to the power of
Okay. What'd you get, Jada?
8 times y to the power of 6 times
Okay. Sharik?
8 times y to the 6th power times z cubed.
The correct answer is 8y to the 6th, z to the 3rd. Part B. What did you get? Start with Maria, Zabari, Ania, and then Alyssa.
64 times 8 to the power of 5 times z to the power.
Okay.
64 8 to the power times 10 to the
Okay. Okay, so we got 3 different possibilities. Alyssa?
64 times 8 to the 5th power times 8 to the 7th power.
Someone said that one. Maria, you had said that? Okay, so we have agreement on one possibility. Someone else want to chime in? Why you want to give it another shot? Go
I
ahead.
agree with Maria and also with
Okay. It is 64, A to the 5th, B to the 10th. So comments, questions on either of these? We'll start with Alicia and then Ania.
I forgot that there was like a second equation, so instead of like I forgot about like the first one, the 4a, and then just did the
Not an equation, it's an expression. Just making sure you know. And I know it sounds picky, but it's a huge difference, so that's why I emphasize that, okay? So you're saying that you just accidentally neglected this and only worked with that.
yeah.
Okay, that's fine. Ania? I'm sorry, how you got A to the 5th? Okay, so you got everything else except the A to the 5th, right? You said A to the 8th, I think? Okay, so we have 4A over here, 4 times A over B squared times, and now we're going to do this, 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 and that. So we got 2 to the 4th times A to the 2nd to the 4th is A to the 8th. B to the 3rd to the 4th is B to the 12th over A to the 4th. See it already? Okay. So just to make sure everyone else is clear, because you're not the only one who struggled with one part of it, is that now if you just want to focus on one variable, since it's all multiplication and division, you can actually just look at that. That's 1a, that's 8 of them, and that's 4 of them. So that's actually 9 on top, 4 on the bottom. 4 on the bottom will cancel 4 of the ones on top, and that's how we're left with 5 on top. Okay? By the same token, you can also see here that we have 2 b's on the bottom and 12 of them on top. 2 here are going to cancel 2 of them here, and that's how we end up with 10 b's. Comments, questions, concerns? Catalina, Tamoy, Kezekiah.
Forgot about the A on the bottom, so I got what
Okay. Ania, is that what had happened? Is you forgot about the A down here? Okay. Good. Very good job. I lost it here and then here. Go ahead.
I got number 1. I got 16 because I measured my own handwriting and instead of doing 21 minus 15, I did 21 minus 5.
So, was it that you forgot to apply the exponent to the bottom?
No, I wrote 15. It's just that the one of the like, didn't.
Oh, okay, so you wrote it, but it was just like a mental little quirk. That's fine. That's honest mistake. Okay? Kezekiah? Never mind? Okay. Other comments, questions? Okay, so I'm going to modify today's lesson. This is the classwork component is a very important part. This is the part where you get to kind of experiment on your own without interruption. Unfortunately, due to some time constraints, we're not going to be able to do that. But here's what I'm going to give you the opportunity for. I want you to copy it down, and I want you to leave some space on your paper. And the classwork will count as an extra credit point. So everyone gets credit for it. So everyone will get a free point. So in terms of this slip, everyone will automatically get a 1 from me. But if you then do it yourself, the workbook is on my website. It's a digital version of the workbook. If you do it yourself, and then bring that in with your homework as well, then I will also give you the bonus points here, and that will bump up your grade quite a bit. Okay? Now, I know that it can be hard. Homework takes a long time for my class, and I understand that. So I don't want you to do the classwork first. I want you to do the homework first, but the classwork will be extra practice that can help you. Okay? Comments, questions about that? So here is your homework assignments. Your homework is page 514, number 16 through 44 even, number 52, number 54A and B, and number 56. And then on page 517, which is just at the end of the section, you have the ready to go on part, and you're going to do numbers 7 through 11. It's a total of 23 questions. You need to read the next section. It's going to give you a big advantage in understanding what we're going to do. And your test on chapter 8 is slated for, let's see, Monday, and then Wednesday, and then Friday. Next Friday.